right, so again, I've got to get back into the virtual desktop because I'd gotten out of it last hour, connecting. And the name of my folder will be a little bit different than yours because sometimes I'm throwing 3 folders out there that all have the same name because they're all 827. So my folder is called 08-27-2014. It's got a C on the end. I leave the C off when I move them over to the in-class folders, but it's the same stuff. All right, so there's my folder right there. All right, that's the same stuff that you see in yours. So I'm just going to, it doesn't really matter the order in which we take them. So I'm going to start with one that's actually pretty easy. And maybe I showed you this one already, but there's a couple things I wanted to say about it. I'm going to go back to that Scrabble game. I tried to go in and put comments in, at least at the beginning. Didn't do a great job of commenting through here. All right. I don't know if you heard this. You know, if you just came, John knows this, and he'll smile when I say it. But this morning, I'm talking to the class, and I'm talking to them about the difference between using plus plus before a variable and plus plus after a variable. You all know what that is, you know, to add one pre-increment or post-increment. And we're sitting there, and I'm getting into it. I must be 30 seconds into it. And somebody, I think the first thing we heard was kind of a scream. There's a chipmunk in here! And they've got that door down there that was propped open. And they think that's how it came in. So one guy decides he's going to be pretty powerful, and he took off his coat, or he had it, and he's going after the thing with his coat. He keeps hitting the ground. And some people are going in there, lifting their legs up in the air, etc. And other people are yelling. Some people wanted to leave. It was funny as hell. John eventually managed, I think you did it, right? Managed to shoo it out of here. And then it just took off. But then somebody else, from what I heard, got it so it went back out the door it came in at. And I told Tammy, who told the custodial staff, so I guess now that isn't propped open anymore. It's still broken, but it's not propped open anymore. And I mentioned to the class that, geez, now 3 to 5 years ago, one of the last times they let me teach summer classes, same kind of thing happened, but it was a mouse. And there were people in here, they weren't all women, that were screaming. There was a guy who was literally, was standing on his chair. He hunched down like this, and he was, don't let it around me. And eventually I was able to take one of the garbages and put it over the top of it. Went upstairs and I told the secretary, I'll call. Custodial staff says they'll be right there. We waited 45 minutes, and you could hear the thing scratching away. I took care of it. It wasn't in as nice a way as they took care of it today. It became splotched, all right? So it didn't go any further. All right. But when we go through here, the switch statement, again, I wanted to make sure you know the switch statement is syntactically the same as what you learned in Java. All right, it's switch followed by what you put in here that is typically going to be either, it's going to be a number, a whole number, or it's going to be a letter like they show right there. All right? And our case is you have to break at the end, etc. And the other reason I'm showing you this is I mentioned this to you on day 1. When we do get into the Swift part of the class, things like the break statement go away. You don't need them anymore. It's not that you can't, you still use them, but you don't have to use them anymore. All right, so again, what we're saying is if your Scrabble letter that you use is an A, an E, an I, an L, an N, an O, an R, an S, a T, or a U, you only get a point for it. If it's a D or a G, you get 2 points for it. If it's a B, C, M, or P, you get 3 points for it. F, H, V, W, or Y, you get 4 points for it. A K, you get 5. J, X, 8. Q, Z, 10. And the default, that means it shouldn't have happened, so I just gave it a 0. All right, so you run the program, and I put in a word like I tried zebra, because I know that's 10. All right, then the E is one of the ones that's 1. That's 11. Then the B, well, that's, I don't think that was up here. That's 3, so that's 14. The R is another one that's just worth 1. And the A is another one that's worth 1. So I should be able to run this program. All right, so I should be able to come in here and say CL Scrabble .c and then run it, so Scrabble. All right, and put in zebra or zerba, but wouldn't have actually mattered. 16, so it works. Not a lot to that, but you should be able to take this, and there shouldn't be anything in here that's a surprise to you, is what I'm saying. This should all be stuff that you've seen before in Java. All right, question? The C-type header, you actually, I don't think you even needed it in here. All right. But I'm trying to remember offhand. As always, I'll let Google figure it out for me. There's where I found the point value. I had it in an old copy that I created, and then I removed it. So I just went online and literally typed in value of Scrabble letters. Character handling functions. Oh, that was it. It's got the 2 lower and the 2 upper. Eventually, when I did it, I was going to set it up so it would only take letters, so you could check all that stuff, and it got to be too big. So in other words, instead of a default, I checked for, when it was a default, I checked for I put an if statement in there with the different kinds of stuff. You know, just to let you know, you shouldn't even have a digit in a Scrabble game type of an idea. And then I thought, well, what the person could put it in upper or lower case type of thing. I just finally, to be honest with you, I just said the hell with it. All right, but I left the thing in there. So that was that one. So that's the first one. All right. And I'm going to keep these in there because, again, as I go and compile and then run these, I'm getting those 2 files. All right, bless you. So I'm going to start with a couple simple ones. Again, hopefully you've seen this. You know, Fibonacci number system where you start with 0 and 1, then you add those 2 together and you get the next number. You add those 2 together, you get the next number. You add those 2 together, you get the next number, etc. And originally, from what I've read at least, Fibonacci was if you have 2 rabbits and you mate them and then you mate them and you etc., how long will it be till you get X number of rabbits? And it's used in probability and some other things that people use. All right. So, again, just to show you, this is a little bit different. All right. What do we have there? We have an array, and all we're doing is we're basically initializing the first 2 elements to 0 and 1. The rest of the elements are not defined. All right? But it's 40, remember, and you know, again, it goes from, literally, it's going to go from 0 to 39. So we're initializing our 0th element, and we're initializing our 1 element, which is our second one. Then we're saying go from 2, and well, it's less than 40. All right, just like other languages, C supports a length function here that you can use, so you can have the array name.length also. Just kept it simple. And in English, this is doing exactly what I just told you that we would do. It's going to come through here and add these 2 and put them here, then add the next 2 and put them there, and it's going to do that 40 times. But again, just to show you that it's very simple to work, and you can have expressions inside of your indices for arrays. Right? We've done that kind of thing before. Okay, there shouldn't be anything new in there for anybody. All right. So again, if I run this one, the program isn't hard. This isn't meant to be a bad joke. The program isn't hard. Remembering how to spell Fibonacci is the hardest part. So there's the first 40. All right. So if you keep adding and you keep adding, you eventually, when you get to the end, you get to what? 63,245,986 is the 40th Fibonacci number. All right. Yeah. Okay. All right. Couple more. I said it's used in a lot of probability and statistics types of things. Yeah. Now the other day, 3:19. I want to finish this by 3:20. The other day, my middle daughter, she gets hooked on TV shows. I don't know why, but she'll just boom, boom. For a while, she loved Friends. Then she loved House. Then she loves this. Now it's Castle. All right, that detective show. So I'm watching one with. I never watched it before. So I'm watching it with her the other day. There's a tie-in. It's the only reason I'm bringing it up. There was a guy, literally what he did was he did probability studies. That's all that he did. So he figured out, for example, if you're going to have a nuclear war, what's the best place to attack? If you're going to ruin a water supply, what's the best place to attack, etc. He became so valuable to the government that he faked his own death because he didn't want to work for them anymore. And then they said, basically, you know too much. You're not going to work any place. So he made it, and there are people like that. Caleb was talking to me last hour, and we were talking about what the government does and doesn't let you know. There's all sorts of people the government employs to do stuff like that that we don't know about. All right? They're basically their statistics heads. They know all that kind of stuff. All right? And I guess somebody has figured out we don't know about it because they figured out it's better that you don't know about it. All right, next one here. What do we have? Well, time is used in this one, all right, for the, I think because we seed the rand in here, okay? And you got the time function. So, John, you know, before you even asked, that's why that one's in there, all right? This is a way, so what are we doing right here? Pound define bool int. It's a more old-fashioned way, but you still see it in there sometimes, all right? What we're doing is we're going to equate these three lines together with one another. So as it says, true is now an alias for 1, false is now an alias for 0, and since bool is of type int, we can return 0 or 1. 0 meaning true, that whatever we're checking has been satisfied, 1 that means it isn't. The reason I decided to show you this one is a lot of older C installations still do it like this. C99 came up with a bool type, but if you're using an older version, it's not supported. All right? So what we want in here is we want to generate 55 6 numbers, but we want the range to be between 1 and 55. Okay? So this may or may not make sense, and I wrote this program years ago in VB and then just went and redid it in C. All right, and what I wanted to show you is this. And again, I don't want you to say, oh, wow, that's the best program I've ever seen in my life. No, it's not, and I know it's not. But all I want to show you right here is imagine, so we've got an array here that's called number taken. All right, and what we're doing right there by just setting that one right there to false is that's going and that's setting location 0 equal to false all the way through location 55. We're setting that equal to false. And the reason I did it and did it like that, just so you know, is notice it's called number taken. I'm going to generate random numbers. But the way my lottery works, I don't want the same number to be generated more than once. Does that make sense? You can't play the lottery, as far as I know, and choose 66666. Even if you love the devil. You can't do that anyway. All right? So what we're doing with this number taken is we're assuming we're going to have a Boolean array, and that'll have every time that, so if I run this and I generate 5 numbers, 6 numbers, it was 6, 23, 8, 19, and 51. All right, that's fine. So so what that'll do is that'll go to location 6, and it'll set that from false to true, meaning that number has been chosen. Why? So if instead of 51 I get a 6 here, it's going to come back and say, oh no, that location is set to true, so that number's already been taken. Does that make sense? Now there are plenty of other ways to do it. But what I liked about this way, not to be funny, and this is no back patting from me, I thought of it. You might be able to go out online and find somebody who did the exact same thing. I didn't. I tried to just figure out a way, well, you know, what way would make sense? So that's why I did it that way. Again, not because it's necessarily a great program, but it's functional, it works. Yeah. Right there. We're not using location 0. We're starting right at 1. Yeah. In everything that we're doing, we're starting right at 1. All right. Okay. So you come in here, and then notice there's another one called lotto numbers. So that's the actual numbers. So in one array, I'm going to be accounting for true or false as to whether or not the number is available. And in the other array, I'm going to have the actual numbers. All right. And then Boolean variable flag. So again, this variable, the way we've got it set up, can only hold, since it's of type bool, which is an int. Although we can have it hold other stuff, the only thing it'll hold in this program is 0 and 1, true and false. All right. So we go through there and we generate the number. All right. So what I'm doing here is I'm coming in here and I'm setting everything equal to false. Why? Technically, we tried to do it here. But I don't trust that. So I'll go back in and I'll write this and let the system make sure everything's false and we start. This right here, I don't know if I've talked about this or not before. Hopefully I have. If that S in front of there means I want to run a random number generator. But the S means I want to do what's called seed, S-E-E-D, the rand. If you don't do this, if you just sit there and type in rand instead of seed rand, the way that any programming language works is it'll generate the numbers for you. But after a while, it does them in a pattern. It might be 50 or 60 times. Then it starts to repeat the same pattern it did before because it uses the same seed value. What this is telling it is for your seed value, always use the current time, including 100th of a second. So it uses a number for the seed value that right now is, what, 15, 26, and maybe 30 seconds. But if I do it now it's 15, 26, and 31 seconds. So it should always be using a different seed value. And the only reason I'm telling you that is you oftentimes see that when people are trying to do random number generation and they want it to be as random as possible, they'll do what's called seeding the rand. All right? Yeah. I'm sure there is, but the way that we're using it in the one array here, in this array, that wouldn't make any sense. And in this array, it wouldn't make any sense because those are numeric arrays. And remember that if they're numeric, the only thing we can have in there are numbers. Now, could you make it 0 and have that be false? Sure, you could do that. You literally could set it up like that. Yeah, yes, you could do that. You could basically always set it so in that case, we want to make sure number taken was set to true and you couldn't change it. We could basically set it up as more or less like a constant in there. To me, all it's doing is it's kind of like this. It's kind of like we're allotting really 56 mailboxes that go from 0 to 55, but you're not allowed to put anything in the 0th mailbox. All right. What you're saying is the same kind of thing. But where with mine, we're just not allowing you to do it. You have to bypass it, whatever. You're basically nailing the thing shut, so you can't do it. But we're doing the same thing. I'm doing it by not using it. You're trying to do it by saying it's there, but you can't use it. And I'm saying that to me, there's not really much difference. All right. So again, we're coming through here, and in English, what we're doing in this loop is we're generating the 6 numbers, and as you go through here, we're making sure that that number is available. All right. If number taken is false, the number is available. So I'm throwing it into my array of the 6 numbers. But then I have to take number taken for that one, and I have to set it equal to true because the number has been taken. And I put this one in here to show you that we're dealing with Boolean arrays and numeric arrays. So you should be able to look at that and figure out what's happening. All right. And if the number's already been taken, this is telling you generate another one. And then when you get all the way done, print out the 6 that were generated. So again, if I run this, two things should happen. First, I should get 6 numbers. All right. Second, they should truly be random. The same number should not be repeating. So if I had it here 45, 16, 45, there'd be an error in my logic. And when I run it again, I should get different numbers. Technically, every time I get this. Now look. Yeah. As Zane mentioned, I did it too fast. In essence, what I did was I grabbed, it was so fast that I grabbed the cached version and just threw it in there. But if I do it literally, so if I come through here and run it, oops. Okay, 1 Mississippi, 2 Mississippi. 1 Mississippi, 2 Mississippi. I should be getting different ones in there all the time. Sure, we could put that into a loop. No, because as long we wouldn't have to, but I would keep that srand in a loop, where it is right now. I'd put a loop around the whole thing. All right. Yeah, to be sure. And again, if you want more on that, you can go out and read on seeding the rand. I should know better than to try to take a drink while I'm talking. All right, so that's that one. Again, as we're going through these, if something doesn't make sense, you've got to ask me. All right, and you have been, and that's good. No, what I'm saying is in older versions, there's no bool type. This will always work, regardless of whether you're using a newer type that allows you to use Boolean or not. But it's not like Java was smart. They said, hey, just from the get-go, let's have this. But in older versions of C, there's C67 out there. There's C70 something or other. There's 88 and there's 99. That's the last one. All right, and I think it wasn't until 99 that they put a bool type in there. All right, here's a game of craps. All right, I went out to some site and found where this would, again, I'm not going to read this. But I actually based this one off of, you may or may not remember, but the book I used to use for the JavaScript class is this one. All right, it's a Untitled book on JavaScript. I didn't like the book, but I love the fact that he put a craps program in it. So I went back and took his craps program, changed it around a little bit, and came up with my own. All right. All right, so literally make more sense just to run this for you. So what is it doing? It's saying, okay, you rolled a 4. Then you rolled again and you got an 8. Then you rolled again and you got a 4. So you won. Whoops, yes. All right, I won again. So it was working out, even though this is done, and I've seeded the rand. It ended up usually I won 3 times, and then I started to lose. All right. All right. So notice again 9. Boom. Eventually I roll a 7, so I lose. All right. So what's the big thing about in here? Well, again, just to show you more of the same. All right. So keeping track of wins and losses. All right, I mean, I'm going to tell you whether or not you won or you lost, and that's going to be the 0 or the 1. Again, seeding the rand. All right. So notice that may be the problem now that I look at it right there, because everything's done in a do loop. What I probably should have done is at the end of that do loop, I should have probably repeated this, or just done it in the do loop. I don't know, but somewhere in here, because this is what's making the whole thing go. So probably if I came down to the bottom here, and seeded the rand again down there. Save it. I'm working with my copy, so it tells you how many wins and losses you have. But if I run this again, it should still run. I didn't make any big changes. Notice I lost right away. Right. And I'll play it again, and I again lost. That to me is showing a little bit more randomness than it did the first time. Now if I say yes and I continue to lose, then something's hosed on it too. Then I have to start looking through it. But again, you know, most of the stuff that you see out there, you have to realize this. C was originally written to be a language for Unix. Did you hear that? And actually, this may or may not surprise you, there was a language before C. You want to take a guess at what it was called? That's correct. First, when they first created it, it was B. Then it was like BCPL, which was control processing language, but it was B. Then when they started making the changes, they called it C. All right, and really like C++, they tried to bring object orientation into it. And before it was C++, that was called C with classes. And people thought that was just too ugly a name. And then they remember the plus, you know, to increment it. That's why it became that. And then the sharp, that was just a Microsoft game. All right. But again, almost exclusively, the code like this that you see, all right, is you can use C and work on it and do stuff from a command line. It's so much more work than it is even in Java. All right, so all the stuff I'm showing you is just like this. Believe me, when we get to even the Objective-C stuff in a few weeks, we're gonna do stuff almost right away. That it will immediately show you how you can use GUI. All right, there's just no GUI in this. But again, do loop just like we have in Java. Well, what are we doing? We're calling a function called play game. So play game, Notice if play game, which means it's a Boolean, so it's got to return true or false, and there's play game. All right, so you're figuring out, based on this, you're going to return true. So notice, you win on the first throw, you lose on the second. Here it's false. Here you want to just keep going type of an idea. All right, and notice here, infinite loop. All right, that might have been where I should have put the seeding the wren. I don't know. I'd have to go back and look at it. It's been a while since I've looked at this program. But it's a simple program, but at the same time it shows a lot of different parts of the language. And that's what I was trying to show you on here. Because sometimes, and it's a great lead-in, Jeff, to your next program, and that's this one. I think correct me if I'm wrong, did I have you do this program in Java? Check or checks. Where I can come and put in a mountain here, 67.48. It's not exactly the same, but it just writes 67 and 48 hundredths of a dollar. All right. Yeah, we did do something like that in Java. You may not remember it, but what you had to do was you had to literally like make a check. All right, so you had to put in the person's name and all that other stuff. This is just a part of that. I tried to put a couple in here that were similar to things you'd done in Java, so hopefully it would trigger your memory. And you'd go back, oh yeah, I kind of remember doing that before, type of an idea. So let's just take a minute or two and look at that one. All right. Write a C program that inputs a numeric amount between 0 and 99. So I literally put in constants for 0 and 99. All right. Then we've got our digits array, which has got, again, going back to what Mark said, we're not using the 0th location. So the number 1, or the word 1 is in the 1's location. The word 2, why? Because that makes more sense. If I was going to create another array here called months, I would do it the same way. All right. And teens, well, I just used 10 in here, but 11 through 19. Tens, well, nothing in the first one, but in here, 10, 20, 30, 40, 50, etc. That should all be stuff you can look at. It's like, yeah, but notice what we have here. These are character arrays, but we're putting the star in front of them because basically we're making them pointers. And again, I want you to understand something, whether I did a good job or didn't do a good job the other day of mentioning it. You typically, the main reason for using pointers, there's two of them. One is the one I showed you, and that is being able to return more than one thing, or change, I should say, being able to change more than one thing inside of a function. The other one is, since they're pointers, they always work faster than the non-pointer equivalents. Always. Because you've already got the address you're working with. That's why they're faster. So, the dollars and the cents figure, digit 1 and digit 2, enter a check amount, all right, and it's expecting like a number dot another number. That's kind of important just so you know. You know, sometimes you'll actually see something like this for a date. I just want to show you this. We may have even looked at an example like this. I don't remember. But I'm going to remove this right away. But I can do this. All right, and let's say that what that represented was month, day, and year. I'm going to assume that they're all ints, okay? That assumes that your input will be a digit followed by a forward slash and a digit and a forward slash and a digit. All I'm telling you is what we're doing inside of that scanf statement, both here on line 39 and on line 37, is you see that you can do, that's not formatting, that's adding additional text to the scanf, which is totally legit. All right, to do that, there's nothing wrong with doing it. All right, now, what you may or may not be aware of, and I'm going to save this again because I made the changes, but I got rid of it. But I want to run this again. Make sure I didn't break anything. Oops. And come back. Now, it's expecting I'm going to put in a number like this, 4.5. All right? It's expecting that. You already see one of the mistakes in it. It doesn't say 0.5. All right? Notice that when I ran it before. Sorry. But the point is, so if I come in here and do that, all right? So I come in here and do this. But notice if I say 4 point, and I hit the space bar a few times and I put in a 5. All right? There's one time it did break. Remember we were trying to get it to break that one day? Because it says 4 point is not recognized. It's not smart enough that it now thinks that that point is a decimal place. And since we defined it as being type int, that's why it breaks. All right. If I come through here and run it again, not that, and I type in for space 5 or point space 5, it didn't know how to handle that. The thing that screwed it up in there was it did not have a numeric value associated with a decimal place. All right. It didn't have a numeric value associated with it, so it just used 0 because it didn't know what it was, and it just totally skipped the 5. So why am I telling you that? Because when you're programming, I don't care if it's C, Java, or something else, you want to check for stuff like this, right? Java, this would be a great way without exceptions to bust your program. All right. But in C, it doesn't break the program. That's actually worse than it didn't break the program. So what you can do, let's say I want this to work. You know, I want to be able to put in as many spaces as I want, etc. Then you've got to go and include the string.h type. You've got to go in there and you have to have it search. All right, you have to have it basically search for blank spaces. And when it finds it, I'd write it out to another array without the blank spaces. Do you understand what I'm saying? I'm going to show you an example of that. Again, it's a tie-in to the next program that I'm going to show you. We'd run it in, instead of having a scanf, we'd put it in there as a get char. And we'd be checking it a character at a time. Then we could run, there's like an isDigit function. If it is a digit, cool. I'm just going to keep putting digits in there until you find a decimal place. All right, so I'm digit, boom, throw it in, throw it in, throw it in, throw it in. Finds a decimal place. Oh, that's my delimiter. Don't throw that in. Then keep looking for digits again and throw out anything that doesn't match those criteria. If you don't do that, either A, you're going to get an error message, or B, you're going to get bad output. So there really wasn't any idiot proofing that was done on this program. That's what I wanted to get across to you. The scanf, there are actually articles on there on the web that will say stuff like, scanf is evil. Yeah, because when you use getchar, you're reading it in a character at a time. Since you're reading it in a character at a time, you can deal with it a character at a time. That's why that's an important thing. All right. In fact, maybe I'm wrong here, but this is a guess on my part. It's been so many years, so. There you go. Scanf functions are evil. Again, Stack Overflow, curious behavior. But you know, typically you're going to see it throughout books because it's an easy way to teach people. Plus, it provides a really good way to say, hey, you know what? If you're using strings, you don't have to use it because of this. But getchar is always recommended. In fact, instead of using printf, there's a putchar, and you'll oftentimes see people do that because it gives you, if you want to, one last time. Even if you think you validated your input, now you can validate the output before you show it to a user. All right, yeah. That's you could have done it without it, is what I'm telling you. All right. Yes. No, it's not really, not in here. But you'll oftentimes see it when you're working with arrays. You're going to see a star put in front of it, right? Especially if you're going to end up passing it. But most of the programs that I put in here don't even have multiple functions in them. All right, some of them have one or two, but I just tried to keep it simple. This was the time that I looked at it this way. Maybe I should have done this better than I did it before we went into the last 3 chapters, gone through this. Because I wanted to show you some programs that are similar to the Java programs so that anybody who's having problems with it, hopefully you can go back and kind of equate that with stuff you've already done in Java. Our guest speaker is here now, so no. All right. So far we've come through here. We've looked at what's that? Okay. When you say parse, are you saying kind of like we did like a parse float, for example, in JavaScript? Because when you're doing a get char, you are parsing. That's what you do when you're parsing. With scanf, there's no way to parse. With scanf, you're at the whim of the person running the program. You think that she or he has a clue. That's why if I'm creating a program, I mean I can find ways to break almost any program. I might have had trouble the other day, but if I would have started doing some of that stuff, we would have eventually broken it. All right, so what we've looked at then thus far in here is we've gone over the check example, the craps example, the Fibonacci, the lottery, all right, the Scrabble example. One more, then we're going to take a break, and that's this anagram, because we're moving towards stuff that's at least a little bit more complex. Write a program that tests whether two words are anagrams. In other words, can I take the letters from smartest and spell mattress? The answer is yes, I can. All right. Can I take the word dumbest and make stumble out of it? It might look like that. It looks pretty much the same, but it's not. There's no D in there. All right, and if it's the same number of letters, there's a letter in one that's not in the other. So this is just sample runs. I tried to put this most of the time in there, put some sample runs. Now, so again, since it got a little bit more complex, ideally at least most, not all, but most of the explanations in here are a little bit wordier as far as the comments. I put these in so that when you start getting the homework, you've got something that you can look at for a baseline as you're starting to go through this stuff. I mean, let's face it, you can go online. You know, if for instance, I didn't do this, but let's say that I'd given you the Scrabble program. Let's say I assign that to you as one of your programs. I'm willing to bet, I'm not going to do it, but I'm willing to bet you could go into Google, type in Scrabble program written in C, and find a pretty decent one. All right? And you may or may not have heard the horror stories. We've had that happen here before. I've had students who've turned in nothing all semester. All of a sudden, they're turning in this code that's stellar. And I mean, it's better than what I did. All right? And a lot of times I've gone in, we've done this before. I'll just Google their first few lines, and I'll find there's usually they're so stupid, pardon my French, but they copy the program verbatim, including mistakes made in comments as far as spelling, the exact same variable names. Now, let's pretend for a second he's not in the class, so I'll just pick on Stefan here. Let's say he was in the class, and he did that. But he changed everything that was in there. He changed every variable name. You know what? I can actually, if it's a real hard program, can all at least somewhat sort of live with that. Because the chances are good, he's going to change some stuff and he's going to break it. And if he breaks it, he's going to fix it. All right? And he's learned something that way. What I can't take, you know, we had this thing, I was taking a class once. It was one of these certification classes. And the teacher said, I'm going to ask a question. And if you're more comfortable, you can all put your heads down. I thought, well, this isn't going to be good. And he asked, his question was, have you ever cheated? Yes, I have. All right, not for a long time, never on my wife. All right, but yeah, when I was going to school, I did. Did I do it regularly? No. Did I feel bad? Yeah, I honest to God did. And I did it once. It didn't stop me from doing it again. All right, but bottom line is, what I consider cheating, you may or may not. When I was going on for my graduate work, what ended up happening is our teachers in some of the classes were so bad, we did the work together. And the guy said he wanted it to be your own work. So to me, the way I looked at it, I was cheating. If I wouldn't have been able to lead, there was a study group of us that got together. If I wasn't able to do that, none of us, with them, none of us would have passed. We all had A's because we put our collective intelligence together. All right, your question. Yeah. But we had a student in the Java class a few years ago, and that's when, maybe I told you about this, that's when Amal was here. And she was teaching a section online. I had a classroom section, but she agreed because I was doing all the work, she'd do all the grading, everything. And I'd never had anybody grade for me before. It was a weird feeling. But we had a person in the class who didn't turn in the first two assignments, which were real easy. We did them as a class, and I taped it. I don't think that would be very hard. We got to the third assignment, and I decided to challenge them. So it wasn't hard, but it was, you know, it made you think. All right, the day that it was due, this person turned in it was better than anyone's in the class, and it was better than mine. All right, and there was some logic in there. We were like in chapter 3 that we didn't go over until chapter 9. So Amma went in and typed in the first few lines of code into Google, just typed them all in as one big line, and it came back that the person had taken the whole thing off, you know. And then we went to the person and said that. I said, no, we didn't. I did every bit of this myself. So we showed it to them, okay, and the person had a special need, okay, and that's not why they did it. The person was very intelligent. I knew the person. They were very intelligent. So we set up a meeting with that person's sponsor or whatever it was here, and we brought the program in. And literally, I made a copy of his program, and we overlaid the other program, and it was 100% identical. And all Amma said was, okay, we'll believe him. We'll take him at his word. You tell me the chances of him creating a program that's 100% identical, up to, there were a couple spaces in there. There were spaces before, like the semicolon, and words spelled wrong. Everything's 100% identical. And he said, now, if he can look you in the eye and tell you that, we'll take him at his word. And so she looked at him. She knew him really well, and he wouldn't say anything. Finally, he walked out. You know, yeah. And Amma was real soft-spoken. I never heard her get mad, never saw. And she said, well, I guess we got our answer, which I thought was kind of a cool response that she gave to the woman there. So, all right. So as we come in here, we do this anagram thing, then we're taking a break. All right. Here's an example, going back. We want to work with it. We have to work with it a character at a time, don't we? Now, you may or may not know what this is doing. All right. Literally, it's changing it. It's doing the character count, so it's going to allow you to put anything in there, whether they're letters or not. All right. But if it's alpha, what it's basically doing is it's saying, you know what? If it's alpha, it might be uppercase alpha. By subtracting minus lowercase a, it's another way of converting it to its lowercase equivalent. Okay? So there's the first word. Then we do the same exact thing. Would you agree that right here, other than the words first and second, would you agree looking at this, that's the same code? Would you agree with that? So we could have written a function and called it. And the first time literally passed in a 1, and the second time passed in a 2. We could have even used the same printf for both functions. That would have been a %d there, or whatever. We could have passed in the word first. There's a lot of ways we could have done this. So this is putting in the first number, a character at a time. This is doing the second one. Then what is it doing? It's trying to go through there and figure out the permutations to say, okay, I've got all these letters, I've got all these letters. And it's looking through while it's doing it, and it says, basically what it's saying is, do we have the same letters in each? We don't care about the order. Do we have the same letters? So again, you kind of look at it this way. It's going through here. I'll take your question in a second, but it's going through here and it's doing this. All right, it's saying, okay, I'm making a separate array. That array has in it a D, a U, a B, an M, a B, an E, an S, and a T. Boom. Then it's going through and it's creating another array for that one. Then it's comparing and it's saying, okay, there's a D in that array. Is there a D in that one? No. Boom, I'm done. Then it does this one up here, and it's got SMA, etc. Okay, so when it does that, it goes through here. Is there an M? Yes. Is there an A? Yes. So it goes through that. But it's got to be able to count and make its way through, and it's got to see, first of all, I don't even think that check's put in there. I don't remember if it was or not, but look, 1, 2, 3, 4, 5, 6, 7, 8. 8 characters, right? So really, the first thing is, don't they have to have the same number of characters? All right. So that's really the first thing. We want to make sure that if we're pulling out the numbers, or letters rather, we've got 8 letters in each one. Because if this one was smartest, and this one was matrices, where it had 10 letters, there's no sense in even making the check. All right? Yes. No, remember this. This right here, that line is because of that line. Many older C programs will just say main paren paren. You'll see a lot of older application code out there that looks like that. C by default assumes that you are always returning an integer. And really, if you leave it out, if you just say main paren paren, you still should have the return 0 in it, even though it'll work without it. Because C always assumes, unless this is something that's non-blank and non-int, so it's float, double, whatever, it assumes that you're always returning an int. That's why 0 typically means success. That's all. All right, so now we've gone through these, so I'll clean up what's left. And after the break, we're gonna actually, we've got just the ones that are down here, but it's the same palindrome program. We're gonna do that first 3 times, and you're gonna see 3 different ways of writing the same program. All right, so that's what we're gonna do when we come back from the break. I actually don't know. One, two, three. I have 4. And I might actually have $1 worth of change. I don't know. I've got a bunch of change before, so there's 4. 25, 50, 75. No, I think it's all here. There you go. Yeah. Oh, that machine will give you 20 quarters.
No, yeah.
And it'll also give you 40 quarters. One day I was walking around and I sounded like a change machine. In that change machine in there, it's always just giving me quarters. I've never gotten anything other than that. No, the actual change machine that's in there. What's really bad is this is how good a dad I am. Usually when I go visit my daughter in St. Louis, I'll do her laundry for her while she goes out with my wife. And I thought I brought tons of quarters. I got down to the end, and all I had left was a $20 bill. And the store that's there was closed because they were doing remodel. There's nothing around there. There's nothing. Unless I want to knock on somebody's door and ask them for change for a 20, which I wasn't going to do. So I'm walking around, and I've got 80 quarters with me. Oh, man, you talk about, weighing you down. No. Oh, what? Oh, yeah, right. What they know as opposed, yeah, that's scary. It really is. When I think about how it was when I was a kid, when I think about how it is now, when I see, and now a lot of my oldest daughter, her friends are having kids. My daughter's 24, and my wife says, "Well, you ready to be a grandpa?" Well, to me, those are always dumb questions. Okay, I'm not ready. So what am I going to do about it? I mean, my wife's sister is 10 years younger than she is. No, she's more than that. Maybe 15. She's a grandma already. She was a grandma before she was 40 because her daughter met a guy at 18. They got married, but she got pregnant right away. So. Yeah, what Super Bowl is this year? I don't know, 47 or something like that. '14 will be, what is that? Is that 43, I think? Is that 50? No, 48. 48 it will be. Now, is that the Super Bowl for this year or last year? I think it's the one for this year because it'll be in 2015, but it's for the 2014 season.